Just a moment, and we will start. This thing is taking forever to load it. Oh, perfect. And now I'm just gonna share my screen and we will start. Okay, just let me know as soon as you're able to see now.
Yes, ma'am. Ma'am, you didn't share the screen.
I did. Are you not able to see?
Yes, ma'am.
Oh, okay, let me stop and reshare. Okay. How about now? Still?
Yes, ma'am.
Are you sure? Maybe try to leave and join again. And let me know
Oh,
if
it's working now, ma'am.
okay, that's good. Yeah. So we are going to focus on this question 8 over here, which is algebraic expressions, and answer all the questions under question 8. Hopefully, we're gonna finish everything because it's just me and you today. So remember the last time when we were meeting, we did algebraic expressions, the laws of exponents and
Yes, ma'am.
basically the continuation of what we did last week when we met. Is it last week? Yes, last week when we met on Friday. No, not on Friday, but on Tuesday. And they say answer the questions related to the following expressions. Then the first expression that we are having here is 2a minus 4a squared minus 8a. Okay. And they first require us or ask us if the two terms, which is 2a and negative a, are they alike, like or unlike terms, and you must provide the reason for your answer. Would you say 2a and negative a are like or unlike terms, and why would you say that?
Ma'am, I would say they are like terms
You say they are like terms. And what would be your reason in this case?
because they both have the same coefficient.
Efficient. Hmm. Perfect. So the answer is correct. They are like terms because the what you call the variable, which is a, and the exponent are the same. Okay. So and the exponent are the same. So it's a to the power of one. Both of them, they're a to the power of one. Remember, if it's just a letter, it means it has what? It has an invisible to the power of one, invisible exponent one. Okay, that's gonna be applicable if maybe let's say we are now multiplying the same variables, which is maybe let's say for example you are required to give an answer of a to the power of 2 multiplied by 8. That's where the one is gonna show. But in this we just keep it um without, because we know that any variable without anything is just to the power of 1. Yeah, yeah. Right,
Yes,
right.
ma'am.
Yeah. And are we happy with that? Do you have any
No, ma'am.
question? That's good. Um, let's 8.1.2. They say write an equivalent expression for 2a minus 4a squared minus that. But let me try to rotate my phone because I don't think you're able to see much. Um, yeah, maybe this is better. Is it better? It's better.
Yes, ma'am.
Okay. Um, let's see. Yes, they say you are required to write an equivalent expression for 2a minus 4a squared minus 8a. Do you know what is it that we're gonna do here? Do you know what we're gonna do here?
Ma'am,
Hi, Manahil.
are we first going to minus the 2 by the 4, and then we also minus the letters and put the exponents.
Tell me what is it that you're gonna have? What is it that you're gonna end up having? Like,
We're going to have negative 2a to the power of 2
wait,
minus 10.
going to have, let me write that down. We're gonna have what?
We are going to the answer is a negative um 2 to the power of 2 minus 8 to the power of 8.
8 minus 8a.
Yes.
Okay, 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 okay. Um, okay. Um, you know what's the problem here, Manahil?
Ma'am.
Yes.
Ma'am, aren't you supposed to combine the like terms first?
Um, yes, we're gonna do that. We are supposed to do that, yes. And what's gonna be the do you wanna answer before I explain?
Ma'am, is it going to be 2a minus 8a minus 4a to the power 2? Then you say minus negative 6a minus 4a.
Okay, that's good. Manahil, you remember the last time when we were having a lesson here? I told you that there's limitation um, when you are adding no, the terms with variables. Do you remember that?
No, ma'am.
So there's a limitation. We don't add everything, especially when variables are involved. So what we do, we add the like terms, okay? Um, I'm not sure if you're already in the class when uh Ole and I were explaining to each other what you call the like terms. So basically, the like terms are variables with same exponent. Okay, so like terms are added together. Any number, any natural number, and any other natural number are like terms. Any natural number with a variable, maybe let's say for example a letter B, and um okay, let me be factual. So let's say you have six. Uh, oh no, gosh, I don't know what's happening. Okay, let's say for example we are having two A like this and 8A. If you look at this and this is what we call like terms. Already we know the numbers are like terms, okay? And also the A, because this is same letter as this one. And we know that if it's just a number, I mean a letter, there's an invisible exponent one. So the exponent are the same. They both have a to the power of 1 and a to the power of 1. So therefore, these are like terms, which means that they can be added together. Okay. But the moment that they are different, let's say for example, we have 2A plus 8AB, right? See, there's to the power of 1, there's to the power of 1, but there's no B, you see? That means that we cannot add these two together because they are not like terms, all right? So we can only add if they have a number and a letter, the letter that is similar to each other, or letters that are similar. Okay, like in this case we have AB and AB. That means these two are not going to be added together because they are not like terms, right? But for case 2A and 8A are going to be added together because they are like terms. They have same variable, which is A, with the same exponent, 1, 1. And I'm going to give you another example. Say, for example, we have 2A. Let me use this one. 2A minus 4A squared minus 4A squared. This is the minus over here. You see, they look like they are like terms, but they are not because of these two over here. So these two make a huge difference, okay? So if you were to add these two together or subtract them or whatever, this would literally be your final answer because you cannot simplify them further. You cannot add them together, right? Because this A over here has a 1. Remember, we said there's an invisible positive 1 when it's just variable with nothing. It's just a letter with nothing, which is this A. A here and a positive 1 there. So you see, here we have 1, here we have 2. We have A, we have A. But this 2 and this 1 makes it difficult for us or limit us from adding these two together. Therefore, these two are not like terms because even though the variables are the same, the exponents are not the same. See? So we cannot add them, right? So in this case, Ole was right. This is what we're gonna do. We're gonna add the like terms being 2A and negative 8. So we're gonna add the 2 with a negative 8. Simply 2 I go 2 minus 8, which is going to be minus 6. Okay. Are you happy with that, Managil?
Yes, ma'am.
Okay, cool. And what is gonna be our answer here is going to be 2 minus that minus 6 is right. And then this one does not have a friend, so we're just gonna write this as it is. So it's going to be 4A squared. So it's going to be 6 minus 6A minus 4A squared. Okay.
Yes, ma'am.
Right. Ole, do you have any question for me? And
No,
you,
no,
Manahil?
ma'am.
Sorry,
No, ma'am.
no question. That's good. Um, let's see, let's see, let's see, let's see, let's see. I just want to give you an expression over here. Uh, let's see. Let me try to wrap this all. And let's see, let's see. Um, 3a. Let's use x. 3x minus 2, 3x squared minus 3x plus 6 minus 6x plus 40. Manahil, which ones have light terms here?
The the 3x to the power of 2, the 3x, the 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 6, and the 6x.
The light terms you said yes. Um.
The light terms.
Mm-hmm.
The light terms are 3x to the power of 2, and um 3 3x, and um the 6x.
Okay, can you remind me what we said about the light terms?
Yes, ma'am.
What did we say about it?
Uh, a light term has needs to be the for example, we count minus 3x to the power of 2 minus 3x. We have to minus 3x um minus the 6x, because the x, the it needs to have a power to be solved.
Perfect. So this means that now our like terms is what? Is 3 minus 3x and 6 minus 6x, okay? Not the 3x squared. 3x squared doesn't have a like term, doesn't have a friend, okay? So now the definition is absolutely correct, and I'm happy with that. We just need to apply it, right? So now the like terms in this case is going to be the 3x, the minus 3x, sorry, and the minus 6x, okay? And then again, we're gonna have another like term set of positive, oh no, of positive 6 and 40, okay? Ne? So remember,
Yes, ma'am.
yes, remember these are numbers, and numbers can be added together. If it's just numbers and they don't have anything, let's say for example, in this case, we have 6 and 40, we can add those two together to get a 46, right? But the ones with variables, because we don't know the value of the variables, remember these are expressions and we don't have the value of the variable, so it's not gonna be easier for us to calculate, right? So basically we're just gonna add the like terms together to simplify it. It's simplification in a way. Um, of making something that looks a bit long to be short, right? And good. Let's go to 8.1.3. They say determine the value of the expression if A is equal to -1. So if A is equal to -1, they want us to give the answer. And Ole, what is it that we're gonna do here? Who else is it here? I haven't checked. Okay. Ole,
Ma'am,
what is it that we need to do here? They say we should determine the value of the expression if A is equal to -1. Ijabulaza.
ma'am, I have no idea.
No idea. Manahil, any idea?
Yes, ma'am.
What is it that needs to be done?
The value of A equals to -1. And we have to find the expression.
Find and division. Determine the value of the expression. So we have to determine the value. If A is equal to 1, do you have an idea? What is it that can be done?
W- We can we can add um the 2A and no minus um the 2A by the 8A.
By the 8A. So basically, this is what they mean. If they've given you a value of A, all you need to do is to just substitute. Ne? All you need to do is to, where you see A, you're going to replace it with -1, because if they say if A is equal to -1. So basically, they mean that you should replace, where you see A, you should replace it with a -1. All right. Does that make sense?
Yes.
Yes.
Yeah. Using the expression that you're having over here. Oh, wait, is that even this? Yes, yes, yes. So this is the expression. So that means we're going to have what? We're going to have 2 into -1 minus 4 into -1. Remember, when you are replacing a variable, you put it in the brackets, okay? Just to be safe, to be, and then 8, sorry, 8 into -1. And then this is going to be, how much is this going to be? 2 multiplied by -1. How much is that? The -2. And -1 to the power of 2 is how much is positive, right? Because -1 multiplied by -1 is +1. +1, multiply it by -4, it's going to be -4. You can use your calculators, guys. I'm not really sure if my sign will be correct. And then +8. So basically, the answer is going to be -6, because -2, 6, 8, then 2. How you guys get? How much did you guys get? Guys, are you still with me? Manahil,
Yes, ma'am.
how much did you get? Yes. So you put the whole thing on your calculator, ne? Do you know how to put a square there?
Ma'am, I got 2.
Got two, Manahil?
Ma'am, do we type in the first sentence?
Yes, we type in the first expression. This one over here that I'm highlighting. Mm.
Ma'am, I got 2.
Two, perfect. I'm happy that everybody's getting the same answer. Let's move. Any question? Do you guys see how simple this was? So all you needed to do is to just replace the variable, which is a, with a -1, right? So if you get this type of question in your junior exam or your tests at school, you should be able to nail it down because it's simply just 3 marks. They just want you to replace the variable that is if if whatever is equal to a certain amount or certain value or certain number, then you just replace with it. Wherever you see it on the expression, you replace it with whatever they said if is equal to. All right.
Yes,
Perfect. Um, are we all good so far?
yes, ma'am.
Okay, and we have one here. They say fully. We have to simplify the following expressions. And the first expression that we are having over here, I'm not sure if you guys are able, yes, you should know. It's -x in brackets to the power of 2. Um, sorry, -x to the power of 2 plus b minus x to the power of 2 minus square root of b squared. Maybe you know what we should start with. I think we should start by trying to work with this one first. Um, this one first, and then we'll go to this one, and then we simplify the this one, and then simplify this one, and then write everything together with this one and the simplified two, and then to make our life easier, right? But you can obviously do it all at the same time. But I'm just saying for simplicity wise, it's advisable to like do the part first and then move to this one because sometimes you get confused because it's long, right? And when it looks long, it's like it's hard, it's not simple. But if you deal with it say singularly, you can see that it's not that hectic, it's not even hectic. So let's start with this one over here. Let's start with minus x in brackets to the power of 2. How are we going to simplify this one? Manahil? Ole?
Ma'am, we are going to say negative, open bracket, negative x, close bracket, open bracket, negative x, close bracket, ma'am.
Like, mm-hmm. Carry on. What's next, Ole?
No, I'm not sure.
Okay. What you're gonna do next is to remove the brackets. Remember, we always preach bottomers. How do we remove them in this case? Gonna multiply the two because there is nothing in between. So that means it's going to be this one multiplied by that one, right? So it's going to be a minus a negative x multiplied by negative x, which is going to be a positive x squared because the negative multiplied by negative automatically turns into a positive, and x multiplied by x, we're going to add the exponents because remember when you're multiplying the same basis, we add the exponents, right? So x multiplied by x is the same as x to the power of 1 plus 1, and which is what? Which is positive x squared. Are we happy?
Yes.
Okay. And so that means so far we are having what? I'm just gonna write it here. We are having x squared minus b, actually plus b minus x squared minus, now let's work with square root of b squared. Square root of b squared. Does any of you know how to remove the square root?
No, ma'am.
No. Manahil, excuse me, guys.
No, ma'am.
No. Okay. Um, this is how you remove a square root. This is square root of b squared. Um, when you remove a square root, um, when it's like this, when it's just the square root, is the same as whatever that's in the brackets to the power of 1 over 2. Okay. When it's just a square root like this, it means when you want to remove the square root, you're going to write whatever that's in the everything that's in the square root in brackets, and then you're gonna add to the power of 1 over 2. So this is how you do it. So in the brackets, we are having b squared. Okay, so I said we're gonna put the b squared in brackets. Let me write it nicely for you guys. Wait. What? Okay. So in the brackets, we have what? We have b squared. So I said we're gonna open the bracket and then have a b squared, and then close the bracket, and then we're gonna have 1 over 2. So basically, that's just how you get rid of the square root. Okay. If let's say for example, we had a square root of 36, um, this is what we're gonna do. Um, you're going to say 36 to the power of 1 over 2. 36 to the power of 1 over 2. Okay, Manahil, I need you to type this in on your calculator and tell me how much you get. And Ole, I need you to type this one in on your calculator and tell me how much you get. So yours, Ole, is 36 to the power of 1. And Manahil, yours is square root of 1 over, square root of 36. Um, we just want to verify that this is really correct. Okay, I just want you to see that. It's, um,
Ma'am. I got 6.
You got 6. Sorry, Ole. Ole, are you still with us?
Ma'am, here it shows me 73 over 2. And when I convert it, it's 36.5.
That is to the power of 1 over 2. How much do you get?
Ma'am?
Are you having 36 to the power 1 over 2?
Yes, ma'am.
So, Manahil, can you try to punch 36 in brackets to the power of 1 over 2? And let's see how much you're getting. Manahil,
Ma'am, I got 6.
you got 6. Um, try to redo it. Ole, let's see if maybe we need to reset your calculator. 36 in brackets to the power of 1 over 2. Ole,
Ma'am?
how much are you getting now? How much you getting?
Ma'am, I got 6.
You got 6. Okay. Let's check with maybe we might need to set her calculator up if she's getting like a different number. Maybe it's probably the settings. Ole, how much did you get now? Did you redo it? And how much you getting?
Oh, ma'am, I was doing a fraction, not to the power, ma'am. I got 6.
Okay. It's absolutely okay, Ole. So basically how you get rid of the square root, okay? And with a 1 over 2, with a square root, with a power of 1 over 2, né? So you put everything in brackets, Manahil. Everything that is in the square root, you put it in the bracket and you power it with a 1 over 2. Ne, Ole?
Yes, ma'am.
Are you guys gonna remember this? Are you guys gonna remember how we get rid of a square root? Oh,
Yes, ma'am.
Yes,
okay.
ma'am.
Cool. So a square root with nothing over here, all right? But the moment we have a square, no, not a square root, but a cube root, let's say cube root of 27, okay? Because I know like it's gonna have like a thing number. When you have a cube root of 27, like that, how do you guys think we're gonna remove the cube root? Do you want to give it a try? Manahil, do you want to give it a try? How are we gonna get rid of this cube root over here?
So, ma'am, we are going to, uh, the answer is 3.
Oh no, I don't want the answer. I just want you to tell me how we're gonna get rid of this cube, cube root here.
We are going to, press shift and then the the square root button, and then inside the button we're going to type in 27, and then we're going to get 3.
Okay, cool. I hear you. But now remember I said when we are getting rid of the square root, we get rid of it with this 1/2 here. We put everything that's in the brackets with what? Sorry, we put the whole thing in the square root in brackets. We put it in the brackets and then we power it with 1/2 to the power of 1/2. Ne? Ole, wanna give it a try, maybe? Ole? Okay, I'm not sure what's happening to Ole there, but when you are getting rid of this 3 cube root over here, you're going to say put 27 in brackets and power it with 1/3. Sorry, not 2, but 3. Okay, so you put everything that's in the brackets and then you power it with 1 over this. Does it make sense? Does it make sense, guys?
Yes, ma'am.
Yeah. So for, let's say, another one, if you have like if you have 4 and you have a 64 and you want to change this one, so you're going to say 64, put it in the brackets, 1/4. So basically whatever that's on here, that will mean that you're going to write whatever that's in the bracket to the power of 1 over whatever that's in here. But if it's just a square root, you know that it's gonna be 2. It's going to be 1/2, right? So it's going to be whatever that's in the square root to the power in brackets to the power of 1/2. But then if it has a number, if it's a cube root, if it's fourth root, fifth root, sixth root, seventh root, eighth root, ninth root, 10th root, and all the roots that you can have, or the nth. So we can have like a formula and say if it's n to, and then we have a number. No, let's not do this. Let's do nth root of x. If we have nth root of x, um what if we have nth root of x, to remove of the nth root, we're going to say x in brackets to the power of 1 over n. Okay, does it make sense, guys? Are we happy?
Yes, ma'am.
Perfect. Is Ole still in here? Ole, are you good?
Yes, ma'am. It just disconnected.
Okay, no problem. But are you with me?
Yes, ma'am.
Doc Hamdi? Okay. Let's try. Let's try to do what? Let's try to. Oh, we are not done yet. So to get rid of the b square root of b squared, how are we going to get rid of the square root over here? How did we say we're gonna get rid of that? Let's start with you, Ole. Okay, Manahil.
Um, we are going to say um op, s- open brackets 6 close brackets to the uh, power of 2.
This is a B, ne?
Yes.
Okay, so I said when we are trying to get rid of the bracket or when we are switching the sorry, not the bracket but the square root name, we're going to take whatever that is in the brackets. I mean, sorry, let me restart. When we are trying to get rid of the square root, right? When we are trying to get rid of the square root, the first thing to do is to put everything that is within or inside the square root in brackets, everything that's in the square root. We put it in the brackets and then we power everything to the power of 1 over 2 if it's just the square root. But if it's a cube root, fourth root, fifth root, that means it's going to be 1 over 3, 1 over 4, 1 over 5, 1 over 6, 1 over 7, 1 over 8, 1 over 10, and 1 over n, right? 1 over whatever root you'll be having, right? So in this case, we have what? We have a square root of b squared. So I said what is inside the bracket? What's inside is b to the power of 2. See, we just placed everything that is in the square root in the brackets. And then now the second thing, which is the last thing, not necessarily the last thing, but yeah, last thing to get rid of that is going to powering it with a 1 over 2. So it's going to be in brackets b to the power of 2 to the power of 1 over 2. So this 1 over 2 here, it represents the square root, okay? That means it's if you show someone this, say what is this? B in brackets b squared close bracket to the power of 1 over 2. They're gonna tell you that this is square root of 1 over 2. I mean square root of b squared, right? Written in a different form. Now that you have something like this, we should get rid of the brackets. So when we're getting rid of the brackets, remember the brackets means multiplication. So that means the 2 is going to multiply the positive 1 over 2, right? So the 2 is going to multiply the 1 over 2. So 1 over 2 multiplied by 2 is equal to 2 over 2, which is equal to 1. So that means our answer is b to the power of 1, which is the same as b. Then that means over here we're going to have minus b. Are we all good?
Yes, ma'am.
Good. And what is it that we have? Um, so now that we are done with everything, see, we're having x squared plus b minus x squared minus b. And this is taking us back to the discussion that we all had earlier on regarding the like terms. I'm gonna ask you guys what are like terms in this expression?
Ma'am, is it b and b and x to the power 2a? Positive b and negative b, as well as positive x and negative x to the power 2.
Okay, perfect. So these are going to be your like terms. X squared and minus x squared are like terms. B, positive b, and minus b are going to be like terms as well. So this one is like term to this, and this ones are like terms both. Right? Not everything together, but just b and b, b and negative b, x squared and minus negative sorry minus x squared. Right. So when we add all these together, and here, what are we gonna end up with? Because these are like terms, Like terms can be added together. What are we gonna end up having? Manayo?
We are going to end up having x to the power of 4 and
So you cannot add the exponents um when you are adding, right? You can only add the exponent if you're multiplying the same basis. So in this case, we are not multiplying anything, right? So that means the x squared is going to add with the negative x, and then we're gonna have 0 because it's more like 1x squared minus 1x squared. So it's 1 minus 1, which is going to be 0. And then positive b minus b, it's like 1b. Um, it's like 1b. It's like 1b minus 1b minus 1b, which is going to be 0b left. Ne, guys? Which is going to be minus b, I mean 0, it's going to be 0 because 1b minus 1b is going to be 0b, and 0b is the same as 0 because 0 times anything is equal to 0. And our answer in this case is going to be 0 because everything will cancel each other. This will cancel that, that will cancel that. And our answer for this is going to be equal to 0. Um, any question for me, guys?
No, ma'am.
No question. There's the last one over here that you can do and send it to me when you guys are done. It's simply the same thing. You're just gonna get rid of the square root. Remember, when you're getting rid of the square root, you multiply what's outside with what's inside, and then you add the like terms, né? And I'm just gonna give you like 15 minutes to complete it. It's just one. 8.2.2, you should take screenshots and send it to me via WhatsApp. I'll just write my numbers here. Uh 076 what 3609. Yes. So when you're done, you can use your parents' phone or yourselves to send me the answer that you would have got when you are simplifying this. Are we all good? So, like in 15 minutes' time, I'll be expecting the answers. Is that clear?
Yes, ma'am.
yes, ma'am.
Okay, guys. Because we're not gonna talk after. It's just gonna be simply you guys sending me the answers. Um, I'll just wish you guys have a good week this week. And yeah, enjoy the rest of your evening. Bye.